Well, after dissecting the periodic table of elements, we are now prepared to begin to do our first electron configurations. The first one we're doing in our class notes example problems is silicon number 14. I would highly recommend using this periodic table that is in your notes. You were provided a copy with all files order of filling. This makes the electron configurations very easy, and you'll soon see why. Here's silicon right here. So we find it first, find it on the periodic table of elements. What can we do once we found that? Well, we know that it's going to end in an S2P2. We already showed that these are showing you where the electrons, how many electrons would be in each of the levels that are going to be filled last. So it has a silicon when we're done should have 2 in its S, 2 in its P on our electron configuration. Now, which S and P? It's on the third level. We see right here, silicon's on the third level. So it should have 2 in the 3S and 2 in the 3P. So I come back over to my answer here, and I'm just going to put down when I'm done, it should be 3S2. When I'm done, it should be 3S2, not 3SW. It should be 3S2, and it should be 3P2 when I am finished. Now, when we do electron configurations, this is what silicon should end in, 3S2, 3P2, if we've done it correctly. That is my valence number. 3 and 3 is my valence number. So how many valence electrons should it have? 2 in the S, 2 in the P. Roman 4 should be above the column. So we look at silicon right here, and there is the Roman 4. So what do? This is where we're trying to go. But you start every trip from square one. So what I'm going to do is just go and backfill the inside missing parts. I'm going to fill in this row, this row. I've already got this row pretty much done. So here we go. How many electrons does silicon have? Atomic number 14. It has 14 protons. We're doing a neutral atom. It's not an ion, so it should also have 14 electrons. Protons are positive, electrons are negative. They should equal each other. So now I'm going to go back, square one. What gets filled first? The 1s. How many elements are in the 1s? There are 2. So I come right here. My electron configuration is going to be 1s2. It's going to be 1s2. And I'm done with that part. Now I come back here. That takes care of that row, 1s2. Now I'm on the second row. How many elements are in the 2s? There are 2. So it's 2s2, 2s2, 2s2. So we have the 2s2. Now I come back over to my periodic table. What's next after the 2s2? I've got the 2p. How many elements are in the 2p? 1, 2, 3, 4, 5, 6. I'm just following the numbers. I'm trying to get to silicon 14. So I'm following the numbers. Hydrogen's 1, helium's 2. There were 2 elements in the 1s. Lithium's 3, beryllium's 4. I'm just following the numbers. 1, 2, 3, 4. Lithium and beryllium. There's 2 in the 2s. What comes after 4? 5. 5 through 10 is the 2p. How many elements are in the 2p? There are 6 elements in the 2p. I'm just following the numbers on my way to silicon. That's my map that I'm following. So now I have to put down 2p6. And with the 2p6 there, I now go back and I take a look. I'm now here at number 10. What comes after number 10? 11 and 12. 11 and 12 are in the 3s. You see it right there. 11 and 12 are in the 3s. There's 2 elements. So as I guessed, I'm going to need a 3s2. So as we predicted correctly, I need a 3s2. And then this is telling me that I think that silicon should be the second one over in the 3p. I come back over here. There's silicon. There's the 3p. It is the second one over. Now, how many valence electrons does silicon have? The answer is 4, but let's find those valence electrons. Where are the valence electrons? My biggest outermost energy level is the 3rd. That's my biggest number. So I've got a 3 and a 3. There's 2 in the 3s. and there's 2 electrons in the 3p. So how many valence electrons does silicon have? It has 4 valence electrons, which is why there's a Roman 4 at the top of the column. So I see the S2 and the P2. How do I know I've done it right? Because I go above silicon, I see the S2P2. How else do I know it right? Atomic number is 14, so it's always smart to double check your electron count. 2, 2 and 6 is 10, and 2 is 12, and 2 is 14. That's how many I am supposed to have. Next one we're going to do, technetium. Atomic number 43. This is where I'm going to find it on the periodic table. I come over here. Number 43, technetium, is right here. Above technetium's column is an S2D5. So when I'm done with technetium, there should be an S2. It should be the 5S2, and I'm in the 4D5. So I can come right on to this thing and just put a little check. How do I know I've done it right? When I am finished, I should have 5S24D5. So when I'm done, I should have 5S24D5 as the last things that I was filling. Now, how do we do it? I need to get to number 43. Where do I start? Start at square one. So I'm trying to get to technetium right here, number 43. I've got to start at square one with this hydrogen and just make my way through all these numbers until I get to technetium. That's what an electron configuration does. So I start 1s2. I start 1s2. Where did I get that 1s2? 1s, and there's 2 elements there. After that, and that's the same thing. It can be in both places. Hydrogen in here, this isn't anything different. That's just this thing put in both places. 1s is full. What comes after 2? The number 3. 3 and 4 are in the 2s. So I have 2s2. So I type that right on here. Then I move up, and it's going to follow the same pattern. These electron configurations follow the same pattern. So I went through lithium and beryllium. They were in the 2s. So now I'm going to move back up. What comes after number 4? 5. I'm just following the numbers. 5, 6, 7, 8, 9, 10. That's the 2p. How many elements are there? There are 6. So in my configuration, I type 2p6. So I go back to the periodic table again. I just finished with neon 10. So now I move over here. This is the 3s. Neon was 10. I'm just following the numbers, 11 and 12. Sodium and magnesium are 11 and 12. That's the 3s. How many elements are there? 2. So I come back to my configuration, and I'm going to type 3s2. And after typing 3s2, I then move back to the periodic table. 3s2 after number 12 is 13. So I'm now moving through this part of the table. Hey, that's the 3p. How many elements are there? There are 6. So I come back to my electron configuration, and I now type 3p6. After typing 3p6, head back to the periodic table again, and now I'm in the, well, I just finished number 18, so I just follow the numbers, 19 and 20. Potassium and calcium are in the 4s. How many elements are there? There's 2. So I come back to my electron configuration, and I'm going to type 4s2. After typing 4s2, I am now going to advance into the sublevel that follows that. After 20 is 21. Right here are 10 elements. That is the 3D, so I will type 3D10 on my electron configuration. After typing the 3D10, head back to the periodic table. I am right here. What comes after number 30? 31, so I'm just following the numbers. 31 through 36, that's the 4p. There are 6 elements there, so I now type 4p6 on my electron configuration. And that takes care of everything that was inside, because I'm now going to go from the 4p6, as you can see, I'm going to go from the 4p6 down to the row that has technetium number 43 on it, TC. So I've done all of this part here. Everything that is not on the row of the element is called the inside of the atom. It's called the kernel. It's the inside, like a popcorn kernel. The kernel's inside the popcorn before it pops or whatever, after it pops. So I finished 4p6. After 36 comes 37 and 38. That's 5s. How many elements are there? There are 2. So as I predicted, this 5s, 2, is correct. Now, how do I know the 4D5 is correct? I pop back out to the periodic table. There's technetium. It's in the 4D. 1, 2, 3, 4, fifth one over. 5D5. It looks like I have everything correct. I ended the trip where I was supposed to. But there is another thing to check right here. The other thing to check is my total number of electrons, and there should be 43. 2 and 2 and 6 is 10, and 2 is 12, and 6 is 18, and 2 is 20, and 10 is 30, and 6 is 36, and 2 is 38, and 5 is 43. My total electrons add up. It should be an S2D5. It is an S2D5 when I'm finished. This part's referring to the last things I was filling up. How many valence electrons does this thing have? There's a great question. There's a Roman 5 right there, or there's the number 5 right there. That is my biggest number. Valence electrons are electrons found on the biggest end, the biggest number we see along that configuration, not the superscripts. The number in front is my valence, tells me that my valence. So my valence number is 5, and there are 2 electrons there. So this element has 2 valence electrons. Don't be confused that there's a sub-level being filled after that. Now, sometimes this is doing an electron configuration in the Aufbau order of filling. Sometimes they do not have you do the electron configuration in the Aufbau order of filling. Now, what does that mean? Sometimes they want the energy level numbers all in the same place. So what would it look like if we put all the 1s, 2s, 3s, 4s, 5s together? Here's what it would look like. This is a common way of illustrating it. So you have the 1s right here, then you have the second level stuff there, there's the third level stuff there, there's the fourth level stuff right here. And there's the fifth level. So sometimes they'll want you to fill it this way. So if someone asks you to do an electron configuration and they don't specify how they want you to do it, you can do it this way, which is directly from the periodic table Aufbau order of filling. If they tell you that they want the energy levels all in order, this is the energy level order of doing an electron configuration. So my fifth level ends up being last, and they just put the fourth level there. This third level gets moved over to here, where the third level stuff is. So if they want it according to energy level, you do it this way. If they don't care, or if they want Aufbau's order of filling, you would do it this way. Now, when technetium goes to react, this is my valence. The first 2 electrons technetium would lose would be out of this level. And we'll talk more about where the electrons are going to be removed from in our next video when we do electron configurations of ions.